solve these quadratic equations and check my dog got me. No dog got hurt. Hopefully still alive. Yesterday I got home, and normally when I get home, the dog like runs to the door and is loud and barks and whines. Yesterday he didn't even come to the door, and I was like, I wonder if he's dead. That was my first thought. He's dead on my bed. But then he slowly came down. But then as I got on, he just became more and more. She got a hover. Yeah, we get my hover around. I was gonna scare down, but she got her dog with her.
Black market.
I have that. I've seen it before. Remember, I hope that you're kind of aware of quadratic equations. When there's an x squared, that's a quadratic equation. If it's equal to 0, you can do the quadratic formula, which maybe you remember. Factoring, I love factoring. I don't know why. Probably because I did it so much when I was in school. But if it's factorable, I usually try to factor it. Some people hate factoring, and some people are really bad at factoring. The great thing is you don't have to factor when you're solving these because completing the square and the quadratic formula always work. Factoring doesn't always work because some things aren't factorable. And so we already did this one, so I'm not really going to touch on that one anymore today unless we decide one that we want to do completely square on. But I want to review factoring, especially factor by grouping, just because it does come up in this class, and I want to make sure that when I do it, you know what I'm talking about. And I want to remind you of the quadratic formula, because if you're going to use the quadratic formula, you have to know it. I won't ever give you the quadratic formula on the test. You have to know the formula. So it stinks if you use the wrong formula. So these first two, hopefully, are pretty easy to factor, especially when there's nothing in front of x squared. Factoring is just undoing FOIL. And since we're solving it, then we're going to set each of those factors equal to 0. But remember the good old days in Algebra 1 when you just got to factor these all the time? Hey, Colmberry. Thank you. Tell her my dog's going to the bed at 10. Right, so what multiplies, I don't know if I really would go through this, but I will. This is like the F of FOIL, this is the L of FOIL, and in the middle I like to say that's the OI of FOIL because it gets added together. So you say, well, multiply is give me x squared, super easy when it's just x squared because it's x and x. But you got to ask yourself, well, multiply is give me 12, that subtracts to give me negative 4. So if you just kind of read backwards there, well, multiply is give me the last number, that subtracts to give me the middle number. You just go through the factors of 12. And the only two that work out to subtract to give you 4 are 6 and 2. And you just got to get your signs right. To get a negative 4, it has to be negative 6, positive 2. And the great thing about factoring is you can check your work. Negative 6 plus 2 is negative 4. Negative 6 times 2 is negative 12. Hooray, we can factor. And then, because they both multiply to give you 0, that means one of them has to be 0. So we just set it equal to 0. And probably you don't even show any work because you just know this would be x equals 6 and x equals negative 2. You get two lovely rational answers. Yes? Yes. Just threw this one in here to remind you that it's not always undoing FOIL. Like on number 2, there's no constant value. You could still complete the square on this. You could still do the quadratic formula. But you also could factor because you could factor by GCF. Right? Like these both have a factor of x, so instead of making my two parentheses, I could just pull an x out front, and then I get x minus 4. That's easy, but people forget it because you get so used to thinking about foiling that you don't know what to do when it looks different. And again, this is still multiplication, so we can set each one equal to 0, and we get x equals 0, x equals 4. It's like, remember how this used to be hard in Algebra 1, and then now it's like, oh my gosh, she's really teaching us something. Then we get to throw in, what if there's something in front of x squared? Usually people say, well, then I just won't factor, I'll just complete the square or do the quadratic formula, which is okay, and I'm totally fine with that method, and I'll try to do it a variety of ways when I'm up here at the board, and that works. If you're going to complete the square on this, it's going to kind of be like the one we just did, because you're going to have to divide by 3, and it's going to get a little ugly in terms of the fractions, but it totally works, and quadratic formula totally works on this. But just to remind you, factor little FOIL thing. So just making your two parentheses is a little bit harder to do, and then trying to just guess and check the numbers. And then you still have to come up with those two numbers. You say what multiplies to give me negative 3, that subtracts to give me 2. So instead of just looking at this number, you have to look at what happens when you put them together. And negative 3 is a prime number. It has to be 3 and 1, right? So instead of writing 2x, I'm going to rewrite it as 3x and 1x. And I want to get 2 out of that. So make sure you do your signs right. To get 2, I would need a positive 3 and a negative 1. 3 minus 1 is 2. 3 times negative 1 is negative 3. So instead of making two parentheses, I'm going to rewrite the middle number using those numbers I come up with. And the first and the last number just come down. So this just becomes minus 1, and this becomes 3x squared. And what we've done is we've taken this trinomial and we've made it into a 4-term polynomial, because now we can do factor by grouping. Now you can group together the first two terms, take out the GCF. You can group together the last two terms, and you can take out the GCF. And that's another way to factor. Again, not required to do that way. Like your worksheet today says solve by factoring, completing the square, or the quadratic formula. And if you want to do the quadratic formula on all of them, it works. But this, I just want to make sure I reviewed this with you. Because now from these two, I can pull out a 3x, and I'm left with x plus 1. And maybe you remember, you want the same thing over here. So when you look at this, you need to pull out a negative 1 so that you'll be left with x plus 1. And remember, factor by grouping, we pull out the both the same. So since they both have an x plus 1, I can pull that x plus 1 out from both of those. And what's left is 3x minus 1. So if you're not a big fan of completing the square with fractions, this gets you no fractions until the very end. But quadratic formula works as well. Because now when I set each one of these equal to 0, I get x equals negative 1. And this one, I would add 1, divide by 3, and I get x equals 1/3. And again, this will kind of come up off and on. Every now and again, we'll be simplifying, and we might factor something out. But for the most part, you can always just go to quadratic formula or completing the square if you don't like to factor. Questions about that? Big memories of factor by grouping? Good memories of factor by grouping? Quadratic formula, that's another thing. This is the last thing here. Oh. Let me skip that. Quadratic formula. We could prove this. I don't really know that you care to see it, but I'd be happy to show you if you're interested. If we started with this and we completed a square, if we subtracted c over, if we divided everything by a, and then we took half of that middle number and squared it and did it to both sides and worked it out, what you end up with is this formula. So the quadratic formula is just completing the square with the standard form of a quadratic equation. People like the quadratic formula because as long as you know the formula, you don't have to remember any steps. You just plug in a, b, and c and you simplify. I will say there's a lot of mistakes that happen with quadratic formula of people plugging in the wrong number or messing up a negative. But for the most part, it's just plugging stuff in, and you have to know that. Did Mr. McClure sing you the song about the quadratic formula? Did Ms. Bai sing you the song about the quadratic formula? You're missing out in life that you don't have the song about the quadratic formula. Mr. Mullis sang a song about the quadratic formula that was like to the Notre Dame fight song, but I don't know the Notre Dame fight song, so I don't sing the one to that. I don't know. You have to find Mr. Mullis on Facebook and ask him to sing it for you. But I used to sing a song to Pop Goes the Weasel, and so instead of saying Pop Goes the Weasel, you say all over to a, right, but now it's not singing. So, but then there's another song that I thought was do your ears hang low, right? Do your ears hang low? Do they wobble to a bro? Can you tie them in a knot? Can you tie them in a bow? You know that song? It was on Barney. But there's a song called Do Your Chain Hang Low, and I'm not cool enough to know that song, but it goes just like Do Your Ears Hang Low. And so it goes like this. Do to A hang low under negative b plus or minus square root b squared minus 4ac. If you practice your quadratic, you will know it automatic. Do to A hang low. One more time. Do to A hang low under negative b plus or minus square root b squared minus 4ac. If you practice your quadratic, you will know it automatic. Do to A hang low. how Mr. McClure is by that they should sing the song, but they don't.
I think you got what you want. I've noticed those little pairs when you have what you want.
Yeah, that would, I think Pop Goes the Weasel.
Probably.
Because that's the one I used to do until I found this other one. I tried to teach my son this song when he was like 4, but he was not having it. So we skipped it. I've done this one. I think I do the Due to a Halo now because it's cooler than Pop Goes the Weasel. It's cooler. It's hipper. It's more hip. So let's just practice this at least with one. Make sure we know how to do this. I found this video on YouTube of these two boys singing that song, and there's much more to the song, but it's a little crazy.
Wait, that song or like a
That-
chain song?
Due to a hang low, like they obviously were doing the do your chain hang low, but they changed the words about quadratics and they talk about conjugates and maybe I'll play it later so you can find it, so you can see how crazy it is. But then you'll also see how much better they sing it than I do.
You sing chain.
I need a 2A on the chain there. Some motivation to go home and find the video tonight so you can hear my awesome singing. And hear about my dog dying. The big thing is make sure you pull out A, B, and C correctly. If it's not equal to 0, make sure you take the opposite sign of C or you move it over. But then it's just plugging it in and knowing it. So negative B plus or minus the square root of B squared. I pretty much always just automatically square B because if B was negative, remember if you type in like negative 9 squared on your calculator and you don't put parentheses around it, it's going to give you a negative answer. So be careful doing that. I just automatically square it. Minus 4 times A times C all over 2 times A. And you can definitely do some of this on your calculator, but show me some work in between because if you don't show any work and you miss the answer, I don't know what you did, right? Like I don't know where your numbers came from or where your mistake came from. So I'm okay if you type all this on your calculator at once, but then show me what you get, or if it's a perfect square, work it out. 12 times 2 is 24, right? So that becomes 81 plus 24, which is 105. Is that right? All over 6.
Yeah.
And then the big thing is, if you can simplify it, you need to simplify it. Start with the radical. If you can pull out a perfect square from this, then you need to. 105 is a big number, but it's not even, so there's going to be no even number that goes in there. 3 goes into there, but 9 doesn't. So I don't think there's any perfect squares that go into 105. Every now and again, 49 might get me, and I don't notice that it goes in there. But I don't think we can do anything. Do not, and here's what I was talking about the other day about people crossing things out. If you're going to leave it as one big fraction, do not simplify this 6 and this 9, because you can't just simplify it and not simplify that. I've found over the years the way to maybe avoid that is write it as 2 separate things, and then you can simplify it. So this is an okay answer. You could also break that up as negative 9 over 6 plus or minus the square root of 105 over 6, which means now, since you broke it up, you can simplify this and make that negative 3 halves, and then you still have the 6 over the 105. So I'm fine with that, but I'm also fine with that. The back of the book's probably going to say that, but I just watch your simplifying because people make mistakes with that. Questions about that? Do you feel like you want to do another one of those, or you feel good to go? You don't. This is in your book. I don't care if you write this down or not. It's just a way to know how many solutions there are. If you don't memorize this or you don't know this about the discriminant, you can always just work it out and see how many solutions there are. But sometimes they ask you, like, how many solutions are there? Are there 2 real solutions, 2 complex solutions, 1 solution? And remember, it's all about the discriminant. And the discriminant is that b squared minus 4ac that's under the radical, because that determines your answer. You don't have to memorize these rules, but it's just kind of nice to think about. That if what's under your radical in the quadratic equation is greater than 0, you're going to always get 2 real answers. You might get 2 nice answers, because it could be a perfect square, or you might get 2 irrational answers, but it's going to be 2 real solutions. If what's under the radical equals 0, right, think about about what happens there. If this equals 0, then you lose that plus or minus. So instead of getting 2 answers, you only get 1 answer. And when we talk about the graphs of that, right, that means that's going to be the vertex of the quadratic is going to be touching the x-axis. And if it's less than 0, just like the ones from your homework yesterday, if what's under the radical is less than 0, it's going to be an imaginary part. So that means you're going to get 2 complex answers, which means if you graphed it, it wouldn't even touch the x-axis. So we'll talk about that as we get into quadratics a little bit more. But I just like to remind you of that, because if it just asks you how many solutions there are, you don't necessarily have to work it out if you know this. If you don't know it, you just have to work it out, and then you tell me how many solutions there are. All right? And again, that's exactly taken from your book. I have a worksheet for you, just because I want you to practice solving this a little bit more. Worksheets are not on your assignment sheet, which means you turn this into me the next day. We'll see what questions we have. Probably what will happen is the juniors pretty much take attendance tomorrow and you get to leave. The seniors will stay here and answer questions, and then if the juniors come back, I'll answer their questions on the worksheet, and then they'll turn theirs in also. So make sure if you're a junior, if orientation gets over tomorrow before class, which I think it will, make sure you come back with your worksheet, because I expect that you turn it in. There's only, it says 7, but there's really only 6 problems because I took off number 6 because it was crazy. So there's only 6 problems, and notice the directions say solve by factoring, completing the square, or using the quadratic formula, your choice. There's definitely some that are easier to do by factoring or completing the square, and some that aren't, but if you want to do quadratic formula on all of them, I'm okay with that. I'm just looking for the answer, whichever way you choose to do it. I think I left enough from there, but if you need more space, you're welcome to use the back or another sheet of paper. Okay? This is like the longest